In this video, we'll be running the Think Shadow-driven photo update example from the Photohub devices DK for ESP32. I highly recommend you start with the simple and revertible examples to gain more understanding into how to perform photo update of ESP32-based IoT devices. You can check my previous videos for guidelines on how to do it. The Think Shadow example demonstrates real-world firmware over-the-air update procedure using the Amazon Web Services IoT Think Shadow service. The Think Shadow is used to trigger firmware over-the-air updates on the device it represents through the cloud. The device itself can be located in any place where Wi-Fi and Internet are available and does no longer need to be connected to a USB port on your laptop or computer as with the simple and revertible examples. The Think Shadow example also detects misbehaving firmware updates and reverts them to the previous version. The prerequisites and tools to run the Think Shadow example are similar to those in the simple and revertible examples. Make sure you have all the requirements on your machine before running the example. If you are new to Amazon Web Services IoT in general or the Amazon Web Service IoT Think Shadow service, you can find relevant introductory as well as detailed technical information on the Photohub Devices DK page. If you have never used AWS before, you must create a new AWS account first. Log into the AWS IoT console and then set up an AWS IoT Think for your board. To do so, you first need to create an AWS IoT policy. This authorizes your board to exchange messages with AWS IoT. In the left menu, choose Secure, select Policies, and then create a policy. On the Create a Policy page, in the Name field, enter a name for the policy. Don't use personally identifiable information in your policy names. In the Action field, grant the Connect, Receive, Publish, and Subscribe permissions. These are the actions that the device will need permission to perform when it runs the example. In the Resource ARN field, enter the wild character. This selects any client or device. For higher security, you should restrict which clients or devices can connect and publish messages by specifying a client Amazon resource name instead of the wild character. Choose the Allow checkbox. These values allow all clients that have this policy attached to their certificate to perform the actions listed in the Action field. After you have entered the information for your policy, choose Create. You then need to create the AWS IoT Think itself along with an X509 board certificate that is used to authenticate your board to the AWS IoT. A Think object represents a specific device or logical entity. To create a Think in the AWS IoT console, choose Manage, click on Things, and then on Create Things. For Think name, enter a name for your Think and click on Next. Select Auto-Generate New Certificate and then attach the policy you created previously. Click on the Create Think button, download each of the certificate and key files, and save them for later. You'll need to install these files on your device. Choose Done. Make sure you delete the initially created and named classic shadow of your AWS IoT Think. Under Manage, locate the Think that you've just created and delete the Think shadow under Device Shadows tab. Now you need to prepare initial firmware version. Open the Think Shadow example folder in Visual Studio Code, go to the configuration header file in the demo product folder and initialize the Wi-Fi SSID and Wi-Fi passphrase constants with the credentials of the Wi-Fi network you want to connect to with your board. Also open the demo product info header file and initialize the demo product ID and the demo product name constants with the ID and the name of the previously created Photohub product. In order to retrieve the ID of the product, go to the Photohub Product Details view on Photohub, click on Settings and then on the Expand button under General. Copy the ID into the clipboard and then initialize the constant accordingly. Update the demo product name constants with the name of your created product as displayed in the product settings. Leave the demo product firmware version as is for now. Open the AWS IoT Think Shadow configuration C file in the product folder and initialize the hostname endpoint.hostname and the AWS IoT conparams.thinkName struct variable fields. They should contain your AWS account's device data endpoint and the name of the previously created AWS IoT Thinks respectively. To retrieve the data device endpoint, go to AWS IoT console and then to Setting. The name of the created IoT thing is available under Manage and Things menu. Open the certificate and private key files included in the ThinkShadow example. Replace other content with that from the certificate and private key files which you have created and downloaded during the setup of the AWS IoT Think for your board. Now you can build and flash initial firmware version. Make sure that Docker is running on your machine, open the integrated terminal, and build the example by invoking the mind make in Docker script according to your operating system. Building the example by running mind automatically generates a script named flash. You can call that script to flash the firmware binary that has resulted from building the example to your board by providing the serial port it is connected to as an argument. Start your serial monitor app, point it at the serial port your board is connected to, and set the baud rate to 115K. Open the configured serial port, observe how the firmware starts up, and verify whether it connects to the Wi-Fi network as well as to its AWS IoT ThinkShadow. Also have a look at the red LED next to the USB port on your board. It should blink with a period of approximately 1 second. Stop your serial monitor app and disconnect your board from your laptop or computer. Use a USB wall charger to power it instead. Feel free to move your board to a different place if you like. Now you need to create and upload the new firmware version to Photohub. Go back to the demo product info header file in the product folder and bump the demo product firmware version constant. Make another change in your firmware like increasing the blink frequency of the red LED on your board by going back to the configuration header file in the demo product folder and decreasing the blink period constant. Rebuild the example using Docker or Make in very much the same way as you did for building the initial firmware version. Locate the resulting new firmware binary file named demoproduct.bin in the build folder using the Explorer view. Upload the new binary demoproduct.bin as firmware version 1.1 to your Photohub product as explained in my previous video. Now you're ready to perform a cloud-triggered firmware over-the-air update. You can do it either interactively through the AWS IoT console or programmatically by using the AWS command line interface. We'll do it interactively. Go back to the AWS IoT console and revisit the unnamed classic shadow of your AWS IoT thing. Open the shadow state document for editing. Add a desired object with a new version attribute to indicate the new firmware version your board should be updated to, and a verification data attribute with the checksum or signature of your Photohub product. These can be retrieved from the details view of your Photohub product. Save the modified shadow state document by pushing update. This will trigger the firmware over-the-air update procedure. Upon successful completion, typically 1 minute or so, the board will be restarted with the new firmware version downloaded from Photohub. The built-in self-test is executed, and in case it succeeds, the new firmware version is confirmed and stays in place. You can see that by observing the red LED on your board. It should end up blinking significantly faster than before, and also by inspecting the shadow state document in the AWS IoT console. It should reflect the new firmware version as the currently running version and include an update status attribute indicating the successful completion of the firmware over-the-air update. In case the built-in self-test fails, the new firmware version initiates the reversion of the firmware update. The board is restarted another time, and the previous firmware version is resumed. Congratulations! You've successfully run the AWS IoT Think shadow-driven photo update example.